Okay, so my other marker was kind of going, so I got a new one. This one says find the equation of the normal line. In order to find the equation of the normal line, you have to first find the equation of the tangent line. To find the equation of a tangent line, you need a slope and a point. So my point, I can say, is f of -2. The cubed root of 3 times -2 minus 2. Cubed root, 3 times -2 would be -6, minus 2 is -8, which is totally fine for me to get a cubed root of a negative, because -2 times -2 times -2 is -8. So I get f of -2 equals -2. So I know right now y minus y1, so y minus -2 is equal to m, I don't know what that is, x minus -2. Okay, so then I have to find the slope. And the way that I find the slope is, make sure you can still see this, is that I do the derivative. But before I can do the derivative, I'm going to actually rewrite f of x. I'm going to change it to 3x minus 2 to the 1/3 power. And now I can see, hey look, I've got a function, something raised to the 1/3 power, within a function. I've got 3x minus 2 inside here. Wow, that means you have to use the chain rule. So I take the 1/3, multiply it by my coefficient of 1, leave the inside alone. My new exponent will be -2/3, because I'm still taking 1/3 minus 1, power rule, going way back, times the derivative of the inside. The derivative of the inside is this business. 3x minus 2, the derivative of that would be 3. So what I'm going to do is just rewrite this, and notice I'm labeling every single time. 3 times 1/3 just goes away. I'm writing it like that. I could write it as the cubed root of 3x minus 2 squared, but it doesn't matter because I know what it means at this point, and that's the important part of simplifying, is so that you know what it means. F prime of -2 is 1 over 3 times -2 minus 2 to the 2/3. I'm kind of going all into this, but this would be 1 over 3 times -2 would be -6 minus 2, -8 to 2/3. I can cube this because the 3 in the denominator, I should move it this way, I can cube it, or I can square first. So I could say the cubed root of 64, -8 squared is 64, cubed root of that, I get 4. Or I could say, well, the cubed root is easier. The cubed root of -8 is -2 squared. Either way, I get a slope of 1/4. And you do all this work and you're like, yes, I got my slope, 1/4. But don't forget, this is of the normal line. So this needs to be -4. In this last one, I actually want you to change it. So the one that was on the paper, get rid of that. And this should say h of x is equal to the square root of f of x times g of x. I don't know if I made that harder to read or easier to read, but either way, I'll leave p of x as it is. It's just f of x plus g of x. And I'm asking you in this one, what's the difference between them? So to find h prime in this one, do you see how h of x, if I rewrite this, would be f of x times g of x, and it's all raised to the 1/2 power? So if I take the derivative, I've got a function within a function. I have a square root function, and then I also have f of x times g of x. So what I'm going to do is I'm going to say, bring the exponent to the front, so multiply by the coefficient at 1/2. I leave the inside alone. My new exponent is -1/2 because I took 1/2 times 1. But I can't forget, this is the chain rule. Wow. So I have to multiply times the derivative of the inside. And the derivative of the inside, this keeps getting more exciting, is a product. So I have to do first derivative of the second, so f of x times g prime of x, plus the second times the derivative of the first. If you want to rewrite this, you can, and you can put this in the denominator. I'm going to go down here. So this would be 1 over 2. This is 1/2 power. If you want to rewrite it as a square root, feel free. Times this mess. I'm running out of room, sorry. That's super messy. That's an f prime of x. It's the same thing that was up here, written down here. And then I can substitute. So if I wanted to find an h prime of 2, or let's say, I don't know, I had a table or something crazy like that, I could go up and I could look at all the things off the table. But it's really, really important. The stuff on the inside, this was a product. So I had to make sure that I did the product rule when I was doing the derivative of the inside. P of x, I'm going to rewrite, and notice I'm labeling, even though it's asking me for p prime. P of x is the same thing as f of x plus g of x is the 1/2 power. So when I'm taking the derivative of that, this, I would get 1/2. I leave the inside alone because I'm using the chain rule. My new exponent is negative 1/2. So look, everything is before, same thing. Times the derivative of the inside. The inside now is f of x plus g of x. The derivative of f of x is f prime of x. The derivative of g of x, g prime of x. That's it. And then I can rewrite it so there's 1/2 square root. So the same thing I did up here. That's the same. But it would be f prime of x plus g prime of x. So just be careful. Okay, one more thing. I'm just going to do this on the same video. I wasn't sure if I was going to or not. But another piece of paper. Going through the list of things that you should know. Here, this is this thing from before. The stuff that you should know. It says memorize or be able to find memorize or be able to find using the quotient rule. This, I would say, this is only as a last resort if you get really desperate. But in your lessons on page 75, make note cards. It's worth your time to memorize this now. Try them. Try them some more. Quiz your friends. That's what all the cool kids do anyway. That's how you make more friends at lunch. Have them quiz you. It's worth your time now. Remember, if you're finding the derivative of secant, don't just say secant tangent. Also, make sure that you know, like, let's say the function is secant of 5x. The derivative of secant 5x would be, well, you know secant tangent is the derivative. But you see how 5x is a function on the inside? So this is the chain rule. So I do the outside, secant 5x, tangent 5x, because the derivative of secant is secant tangent, times the derivative of the inside. So times 5. You can put the 5 at the end, you can put the 5 over here. But don't forget about that. Someone will, don't let it be you. Know what it means and how to calculate the slope of the tangent line. Slope of the tangent line is the derivative at a particular place. So make sure that you're just aware of that. Slope of the normal line is you find the slope of the tangent line. It's the opposite reciprocal. This, you know those charts that we made? Don't forget about those. If a function is increasing, it means its slope, or f prime of x, is greater than 0. If it's decreasing, that means f prime of x is less than 0. It says know how to rewrite expressions such as 2 over square root of x plus 3 sine of x as this. Meaning, if you get to the end, I don't know, and if it's so specific, you definitely want to look at stuff like this. And you get to the end and you have a problem, and your derivative is this, plus 3 sine of x. And you want to write it as a single fraction. Remember what you do is you need to have square root of x over here, but I can't have the square root of x in the denominator because I just put it there unless I also multiply it to the numerator. Now I can combine like terms. Square root of x becomes square root of x. See how this is 2, it's from there, plus 3 sine of x, square root of x. So it's just coming from getting common denominators. Make sure you know these. Power rule. The first times the derivative of the second plus second derivative of the first. What am I doing with my life, guys? That's a product rule. Sorry, I was looking. Yeah. Power rule is just you take the exponent times the coefficient and then subtract 1 from the exponent. Product rule. First derivative of the second plus second derivative of the first. Quotient. Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. Make sure that you've got these over and over and over again. Say them to yourself. Chain rule. Take the derivative of the outside. Leave the inside alone. Times the derivative of the inside. So Know these, super important. That's why I'm putting this. And as always, come and see me if you need help. I'm willing to help you, and then I can make these exclamations into smiley faces. Oh, that's super creepy. Anyway, good luck. You're gonna be great.